Hi, welcome to R2E, and in today's video we will solve problem number 3.12 Capstan from Daniel Kleppner and Kolenkow. So let's see what the problem says. So it says a device called Capstan is used aboard ships in order to control a rope which is under great tension. This rope is wrapped around a fixed drum, usually for several turns. The drawing shows about a 3/4 turn. The load on the rope pulls it by with a force TA, and the sailor holds it with a much smaller force TB. Show that TB equals to T to the A e to the power minus theta, where mu is the coefficient of friction and theta is the total angle subtended by the rope on the drum. Great. So let's consider a very small length element on the rope, something of this small. And then let's draw the force diagram. Okay, so if this is the force diagram, so okay, so this is T and this is T plus dt, and then you have in the middle, now we can connect these vectors. Okay, so here this angle is d theta by 2, this one is also d theta by 2. Now more force is on this side, there's less force, so the friction will be pointing here, and obviously there will be a normal here. Great. So now let's balance the force. In theta direction we have, okay, this will be d theta by 2, and yeah, again here it will also be on this side, this also be d theta by 2. Great. So t plus dt cos d theta by 2 minus of friction minus of t cos d theta by 2, this is equal to 0. Now this here and this cancels out, so we have dt equal to f. So here, by using the fact that cos d theta by 2 is roughly equal to 1 in the small angle limit, okay, so if limit d theta goes to 0, obviously d theta is already very small, so it's approximately equal to 1. Great. Now in r hat, so we have t sine d theta by 2 plus t plus dt sine d theta by 2, this is equal to the normal, and this will be 2t sine d theta by 2 plus dt sine d theta by 2 equal to normal. Now sine d theta by 2 is roughly equal to d theta by 2, we can show that using Taylor expansion. And now here I will only consider, so this implies this is t d theta plus dt d theta by 2 equal to normal. Now only considering first order terms, so for the first order terms, that will be terms that are only dt, like d theta, not terms like dt d theta, because if you take the sum of the power of the derivative here, it turns out to be 2, where here it is just 1. So now we will just neglect it, because this term here is much smaller than this term here. So we have another equation, t d theta equal to normal. So now we have two equations, this one and this one. So by using these two equations, we know that t d theta equals to, mu times t theta, mu t d theta equals to mu times n, that is equals to the friction, and friction is equals to dt. This implies that dt equal to mu t d theta. So this implies that integral from tb to ta dt upon t equals to mu times theta, as taking it the limits from 0 to some finite angle. So this will be ln of ta upon tb equals to mu d theta. This implies ta equals to tb exponential of mu theta. So this implies tb equals to ta exponential of minus of mu theta. So we have proved what we started. So yep, so with this we are done, and see you in the next video.